In recent years, computer science has made it possible to create or reproduce people and universes. The computer can even simulate camera movements, giving the illusion of walking through the images. But the border of the image puts blinders on us, which prevent us from seeing the entire scene. Since we can't see where we want to, we would like to control the choice of images. The interactive compact disc gives us a rapid access to images written on a high-capacity disc, such as a CD-ROM. But this interactivity is relative because the images and the interactions have been planned in advance.
A
lot has been said recently about virtual reality, but the ideas behind it are not new. What is new is that the technology has advanced to the point where today a large number of people can put these ideas into practice for a reasonable price. Virtual reality is a collection of technologies brought together to give the impression of being immersed in a computer-generated 3D environment. These technologies allow the user to move around freely within the environment and to interact with the constituting objects. Helmets, glove, joysticks, screens, and mice. These are some of the key words used when building such environments.
Shut the door, keep down the south. Shut the door, keep down the south.
The universe in which we find ourselves is a simulated space. The operator can move at his own rhythm and act in real time. He has the sensation of total immersion in the image. Artists quickly understood the advantages of these new technologies. The French artist Criqui developed, along with Medialab, an interactive universe where one can enter his paintings and explore them from the inside. The computer senses the slightest changes in the user's orientation, as well as the turning of his head, and immediately passes them on to the virtual world. There is a high level of interactivity, and at any moment we can transform the space in which we have the sensation of being immersed. In this universe, an object, such as a hammer, can affect other objects.
Within the medical field, Medialab has developed several applications of virtual reality. For example, an application of surgical assistance, where you can wander around inside a nasal passage reconstructed from scanner slices. Then there is an application where you can visualize a beating heart. You can actually hear it beating and move around inside it. The potential of this in education is very promising. It becomes possible to visualize areas that you could not see with a camera. For example, when using an endoscope in the nasal passage, there are various tissues which float around inside and which get in the way. But with computer graphics, you can easily position the camera exactly where you want.
At any moment, the surgeon can see highlighted exterior views showing the exact position of his tools. If he gets close to dangerous areas that were determined earlier, he is given both a visual and an acoustic warning. The counter seen on the screen shows the distance from the camera, the future endoscope, to the pre-selected danger zones. It is precisely this point which constitutes the most valuable aid for the surgeon, giving him valuable assistance during the operation.
Future applications which are currently in development at Medialab aim mainly at perfecting these techniques so that we can actually bring them to the operating table for everyday use by surgeons in order to make operations easier.
It is now possible for speakers at a great distance from one another to be joined virtually in the same universe. This marriage of computer graphics and communications is called televirtuality. This demonstration showed how two users, one in Paris and one in Monaco, can move about and interact in the same virtual universe, the Cluny Abbey. Users perceive this universe on the stereoscopic screens of a special helmet equipped with position sensors. They see each other in the form of simplified figures and can hear each other through a parallel telephone hookup. They move around using a joystick or other man-machine interfaces and can interact with certain elements of the universe they share.
Simulation and televirtuality are being used in increasingly varied applications. For example, scientific visualization, telecommunications, design, architecture, and telemanipulation in hostile environments. We are just now beginning to see the concrete applications of these technologies, but clearly this is only a first step. Our role is to make this technology accessible to the greatest number of people possible, and to make the sensations generated and the worlds created with these technologies more and more convincing and realistic.